In the cloud in a bottle experiment, we note that the cloud disappears, the water droplets disappear when you increase the pressure and temperature, and they reappear when the pressure and temperature decrease. So less pressure, droplets; more pressure, droplets disappear. So if you take that as part of physics that is real, then we have to figure out how can a cloud form and expand in the real world. And here is what I think happens. So a cloud is an area, a small cloud is an area of two-phased fluid flow. So you have the droplets are flowing down and the air particles are flowing up. Now that's pretty obvious when you think of it. So because the droplets are heavier than the air particles. So let's ignore what made the droplets form for the moment. So it's because they formed, it's warmer than the air beside it, because a lot of heat gets released when condensation happens. So it's a warm area, it's possibly rising slightly due to its warmth, and irrespective of the rising, the water droplets are falling down, the air is going up through the water droplets. So that means that at the air particles that are coming in here, or the pocket of air that comes in here, goes up through the cloud. So what happens? So it came from here, say outside the cloud, goes up, and as it goes up through the cloud, it is gaining heat because this is warmer, and it is also saturated because it's surrounded by these particles, droplets of condensation, and it's in equilibrium with them, which means that when it comes out here, it's saturated. And also, the moment it leaves the cloud, it is no longer impeded by the water droplets going down. So that means as soon as it comes out here, it speeds up. And if you consider the entire top of the cloud, the warm air, warm saturated air coming up and out and speeding up, what happens? You have the warm air going up, it's cooling, and because it's speeded up, it has taken up more space, and that means that you get condensation up here. So now the same thing happens. This condensation will be sinking down through rising air, and given that you're having heat released in this area, and the long-term product is dry air up here, the air coming up through the cloud has lost its moisture. So what you're getting in effect is almost like a volcano. You can see the clouds going towering sometimes, but you can't see the water vapor. Water vapor is invisible. So up the top of the cloud, it's like anywhere you see one of these big clouds expanding, you are getting an air fountain going up into the sky. And that is why clouds are forming low pressure when there's condensation happening. Now at the bottom of the cloud, you have the water coming out. You're going to have droplets, larger droplets coming out and falling away. And I think that probably means that the bottom of the cloud, if you're getting droplets falling away, say it's drizzle, it's falling away, this is going to pull down the bottom of the cloud, the air in the bottom of the cloud, and same thing as at the top, you're going to get droplets forming heat released, and at the bottom of the cloud, that means the cloud will, even with the water droplets coming down, the cloud will be rising, and the ultimate, what's happening is it is sending air up into the heavens. It is drying the air, and I think that's what's going on. And people don't see it that way, as far as I know. And it's a different way of thinking of it. If you watch the cloud videos carefully, you'll see that, I think you'll see that that's actually what's going on in many of the cloud videos in my biotic pump playlist. And it's worth just thinking of it in that way, and think of, you know, as the air comes out here, it's coming out in a kind of a three-dimensional fractal. So you know how you have all these patterns in 2 dimensions, these patterns, whatever the hell they're called. What you're actually getting is a kind of a fractal pattern happening on the top of the cloud as the water, as the air, the dry air is leaving the cloud. The dry, warm air is leaving the cloud. Thank you.